Hi everybody, it's Mrs. Peachy from your WCA Physics class, and we are going to be looking at a tutorial today for your sound laboratory, which is in Unit 1, Lesson 6 of second semester physics. So you can see on the screen here, right now I have slide 3 of this lesson up, and this is the link that will take you to the sound activity. Before we kind of go on with that sound activity, however, I do want to go back a slide with you, and I want to draw your attention to the description here. It says here, you will explore how frequency and amplitude affect the speed of sound, and your hypothesis should be answering these questions. How does the frequency of sound affect the speed of sound? And how does the amplitude affect the speed of sound? So you should hypothesize, and that should contain an if, then, because statement. Remember too that I do want you to use your textbook as a resource here and to cite the textbook in the section, the page numbers that you were able to use to help you locate some answers. Prior to making your hypothesis and introduction, however, you will be doing a hypothetical lab, just like you do for most things. So in this hypothetical lab, you are going to come up with an idea to demonstrate the principles of sound and how frequency and amplitude affect the speed of sound. Talk about the materials you would use, what you would measure, what results you would expect, and what might have happened if the results are different from what you expect. Remember, for this part here, this is essentially going to be your sources of error. So don't just tell me that you have human error. That could be lots of different things. So make sure you specify what that means. A lot of the different types of error that you might look for are error in equipment. The setup could be, done incorrectly. What could be wrong with the setup? Think about error in measurement, error in calculations. Maybe your calculations were done incorrectly. Potentially, there could be external variables that might be affecting what you see. So you have to make sure you account for all of those external variables. Okay? And it's really important as well that whatever you are trying to test is actually something that's being tested for. So make sure that your experiment has been set up appropriately. Now, to remember what needs to go into your lab report, go to my website. And you will find, hopefully, well, actually, I need to go back to, oops, that's the physics first semester. Okay, I'll get that up there shortly, but there will be a rubric up on Physics B. It's the same one you guys used first semester, okay? So just make sure you're using that same one, but I'll make sure I post it back up on the Physics B site as well. When you get back to this page, page 3, there is a link here to take you to a PhET sim. So I have that open for you here. And then you'll be following along with the lesson. It'll tell you what to do on this sim. And I think I have the sim open even right here. Okay. So this actually does have sound. You do not have to enable it. You can just observe the sound waves, or you can enable the sound and you can hear it as well. You want to play with the volume there though so that you're not bothering your ears too much. Okay, so on slide 4, hang on a second. Oh, sorry about that. It's accidentally double clicked for me here. Oh, there we go. Forgot to scroll down. So you're going to see it says at the top of the screen you will see several tabs. Begin by exploring the tab labeled Listen to a Single Source. And it says first make sure the volume on your computer is on. At the bottom of the field on the right side of the screen there's a box called Audio Enabled. Click it on. You can play with the frequency and amplitude sliders to hear how changing these values affects the sound you hear. You should also notice the way the sound waves are depicted in the lab. The areas of dark color represent compressions, and the areas of light color represent rarefactions. Notice how the width and colors change when you move the sliders. Take some time to become familiar with the screen. Now click on the tab labeled Measure. The experimental setup is shown below. The experimental setup consists of a speaker that emits a sound, as in step 3. You will see a ruler and 2 blue lines. You can click and drag to different parts of the screen. At the bottom of the screen, there's an arrow that you can click to start and stop the animation and allow you to step through the animation. On the right side of the screen are 2 sliders. One allows you to change the frequency of the sound and the other the amplitude. There is also a stopwatch. Spend some time playing with the lab to become familiar with it. Create a data table on your spreadsheet program. Your data table should have the following columns: trial, frequency, time, and number of wavelengths. Your table should include enough rows for 6 trials. Move the ruler so that it lines up with the front edge of the speaker. Move one of the blue measuring lines so that it is 5 meters from the front of the speaker. Pick a frequency and record it on your data table. Click on the start button and on the stopwatch. When the sound wave just hits the blue line, stop. Record the amount of time it took for the wave to move 5 meters in your data table. Count the number of complete waves that have emanated from the speaker. Remember that a wave consists of an area of rarefaction and an area of compression. You should estimate to the nearest tenth. Record this number on your data sheet. Press the reset button on the stopwatch. Repeat the last 2 steps 5 more times using different frequencies. Okay, so we're going to be looking basically at calculating the speed of the wave. So we're going to look at the distance the wave traveled in a specific period of time, but we're also going to be counting the number of wavelengths here, okay? So all of these things are going to be included in a data table along with the frequency. So that's going to be pretty important. Trial number, frequency in hertz, time, and number of wavelengths for 6 trials. So let's go back to this here. Okay, so what we're going to do here then is, you can see these kind of waves that are coming out. You can click and drag these blue lines. Ah! Can't seem to catch this one. There we go. Oops, I'm going to actually move this one just a little bit so it goes just 5 meters. Okay. Gonna reset this. Clear the wave. I'm gonna pause it. Okay. And then we gotta start the stopwatch here and play button. It can be kind of hard to do that at the same time, but I'll see what we can do. I'm gonna hit play and then I'm gonna hit the start button. This is really hard for me. Stop this. Let's reset it. I want to measure like one wave on here, I think. And then we'll measure the time it takes for that wave to get to the 5 meter mark. Pause this. Let's try this again and see if I can do this. Somehow I feel like I'm missing something here. What is that little? Can I just push enter? No. Just a moment. Okay, and this is what I'm supposed to be doing, so this is a little bit tricky. Let's see. Okay, so you really do need to just wait till it gets to the 5-meter mark and then stop it. I'm gonna set this down here just to make it easier. But yeah. Ah! That didn't work. Trial and error, people, okay? Maybe it'll make you feel better that I'm having some troubles here. Why didn't it stop? Schnookers. Oh, it is stopping. Okay. Booger. Stop. Okay. Didn't start. Come on. What the heck? Okay. This is really not super accurate, is it? Okay, so there's my time. 0.0119. That's how long it took to go. And then I would pause it, and it doesn't really matter about counting the wavelengths. You can count the number of wavelengths here. Remember, each one of these is 1. So 1, 2, 3, 4, 5, 6, 7.5 wavelengths. My frequency here is 500 hertz. Okay, the timer part is going to be the trickiest part because that part is very touchy with your fingers. You may have to just really eyeball that wave pretty well. But once you got that, you can get all the data, and then you're going to do some calculations. And it's going to ask you to calculate speed 2 different ways. Okay, now remember that velocity is frequency times wavelength, but velocity is also distance divided by time. So that's the 2 different calculations you need to do to figure out the velocity of the wave. Don't forget that looking at meters per second, and that a hertz is in terms of wavelengths per second, cycles per second. So there's that too. Okay, so just kind of play with that a little bit till you can get that down a little bit better than maybe I can. It might help to have somebody help you with this, but I don't even know how you would click on 2 things simultaneously because you only have 1 mouse. So I'm sure there's something that you guys can figure out that I'm doing a little bit wrong there. Otherwise, you know, answer the questions that go along with it. And let's see, I'm going to check one more thing real quick here. Don't forget to show your calculations for velocity. You're going to use your book to figure out the medium through which the wave's traveling, because you should be able to figure that out based on the speed of the wave. And data tables. It does not need a graph for this one. Hopefully that makes sense, everybody. Good luck. Let me know if you have questions. I'll talk to you later.